the last video, we looked at calculating enthalpy changes for phase changes. Now we're going to take a look at enthalpy changes in terms of chemical reactions. Up to this point, we've understood that reactions have reactants and reactions have products, but reactions also have an energy change, a net energy change associated with them as well. So if that net energy change is negative, then that means it's an exothermic reaction, and exothermic reactions are going to have heat listed as a product, okay, meaning that heat has been given off. For an endothermic reaction, however, we know that the net energy change is positive, meaning that heat is, or the delta H is positive, and so that's going to list heat as a reactant. So what we can do now is we can use this to figure out, okay, if I've got this much of a substance and then I do whatever with it, I can figure out how much energy is lost or gained based on how much of a substance that I have. So if I look at example 14.5, it wants to know which one's endothermic and which one's exothermic. Well, over here, I see that I have energy on the product side, and energy on the product side gives me an exothermic reaction. For this one, energy is listed on the reactant side, and so that gives me an endothermic reaction. So now what I can do is I can use this information to do some calculations. So let's go ahead and take a look at how we can use that with calculations. So let's first off examine this formula right here. Now before we do that, I'd like to get rid of this. Okay, that gives us a little more room. So let's take a look. It wants us to calculate the amount of heat in kilojoules absorbed when 5.66 grams of carbon disulfide is formed. So my given in this problem is 5.66 grams of carbon disulfide. So I'm going to start off by saying I have 5.66 grams of carbon disulfide. I'm trying to get to question mark kilojoules. So now this looks like a problem that we've seen before. So I can go from grams to moles, but now instead of going from moles to moles, I don't really have moles of energy, okay? So what I'm going to do now is I'm going to go from grams to moles, and then I can actually go from moles straight to kilojoules by modifying our T-chart just very slightly. So let's go ahead and make a T-chart now for this problem. And so I'm starting off with 5.66 grams of CS2. So I'm going to put that right here in my T-chart, 5.66 grams of CS2. I'm then moving on to moles of CS2. And lastly, I'm going to end up at kilojoules. So I know to bring everything down, grams of CS2, moles of CS2. So now this one's going to be the same, okay? I've got moles to grams. I know that, of course, I'm going to use molar mass for that problem. So I'm going to put a 1 in front of my mole. The molar mass of CS2 is 76.14. This is where the difference comes in. When I'm relating kilojoules to moles, I'm going to put the number of kilojoules that I have, which in this case is just 89.3. So I'm going to put 89.3 right here. But for the moles of CS2, I have to go back and look at the coefficients, okay? The coefficient I have in front of CS2 is assumed to be 1, so that's just going to be a 1 right there. So now I can say, okay, well, blah, 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 do my math, type that into your calculator, and you get 6.64 kilojoules as your final answer there, all right? So now let's go ahead and take a look at a different problem that has the same. It's going to have the same formula, or yeah, the same chemical equation, but we're just going to have a different coefficient. So let's take a look. Actually, I'm just going to get rid of this problem right here. All right, so this is that second problem that we were just taking a look at right here. It wants us to calculate the amount of heat in kilojoules absorbed with 16.83 grams of sulfur. So I've got 16.83 grams of sulfur, and I want to find question mark kilojoules. Same thing as the last problem, guys. I'm going to go from grams to moles and moles to kilojoules. The only difference in this problem is my number of, or my coefficient in front of sulfur. Okay, so once again, I'm going to start off with 16.83 grams of sulfur. I go to moles of sulfur, and then I go to kilojoules. I bring everything down, grams of sulfur, moles of sulfur. And so now I can say, okay, well, I know 1 mole of sulfur is molar mass of sulfur is 32.07. Now for right here, I have to relate the coefficient, which for sulfur is 2, and my kilojoules is still 89.3. So now when I type that into my calculator, I get 23.44 kilojoules. So that's how these problems work, guys. We can work these problems the same exact way as we would a just a regular old mole road problem. So let's go ahead and take a look at one more problem, and that's going to be the next problem on your page. So it says the production of iron and carbon dioxide form iron 3 oxide, yada, yada, yada. It tells you that you have an enthalpy value of negative 26.3 kilojoules and wants to know how many kilojoules are produced when 3.40 grams of carbon monoxide reacts with excess iron 3 oxide. So what we need to do now is we need to determine where this energy is going to go. Since it tells me that my delta H is negative, I know that my energy is a product. So I'm going to go ahead and put negative 20 point. I'm going to go ahead and put 26.3 kilojoules. Now let's think about this. If something is releasing 26.3 kilojoules, it's releasing that in a positive number. Okay, it's not releasing negative energy. So I'm going to actually put positive 26.3 right here. Even though it says negative, the negative just tells me that that 26.3 is on my products side. So now I can say, okay, well, I've got 3.40 grams of carbon monoxide. I'm going to go from grams to moles, and then I'm going to go from moles to kilojoules. So now I can plug that right on into my T-chart, starting off with 3.40 grams of CO. Then we go to moles of CO, and then we go to kilojoules. Bring my grams of CO down, bring my moles of CO down, and so that's going to be 1 mole for 28.02 grams. That's just the molar mass, if you don't remember. For every, now kilojoules to moles, remember, I'm going to use my number of kilojoules in front of kilojoules, so that's 26.3. My moles I have to get from the coefficient. So my moles of carbon monoxide is 3. So now I'm able to plug all this into my calculator, and when I do, I get 1.06